Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Let's talk about how we can graph some cosine functions. Very similar to graphing sine functions with just a couple differences. So at the top we see y equals a cosine b of x. Once again, a and b represent the same thing as they did in our sine function video. So a is our vertical stretch or shrink, and that's by a factor of a. Once again, this is going to change the amplitude of the graph. So the amplitude is just going to be the absolute value of a. Now for b is going to change the period of the graph. This is going to represent our horizontal stretch and shrink, and it is 1 over a. So it's kind of opposite of what it looks like, right? If we see a 1/2 there, it's actually a horizontal stretch by a factor of 2. If we saw a 2, then it would be actually a horizontal shrink by a factor of 1/2, right? Very similar to all the transformations we've done for previous functions throughout the course. So our period, how we're going to find it, it's 2 pi divided by the absolute value of b, okay? All right, now let's use, just like we did for sine functions, 4 sections of our graph to help build our graph. So we know that our y-intercept is not the origin, that's for sine functions. For cosine, it's 0, amplitude, or whatever our value for a is. And we're going to also split the graph into 4 sections, with the furthest section to the right being our period. Then we'll split that into fourths from there. So notice what happens. We're at 0a, and then we follow this pattern, right? 0a, then we go down to 1/4 of the period would be 0, a half of the period would be negative a, 3/4 we're back up to 0, and then back to the period at a, okay? So let's look at 2 examples where we graph some cosine functions. Number 1, we have g of x equals 3 cosine pi of x. So we notice that a is 3, so our amplitude is 3. That's going to give us a vertical stretch by a factor of 3. By a factor of 3, good. And now our period here, we see that b is pi. So our period is going to be 2 pi divided by the absolute value of pi, which is just pi. And our period is going to be 2. So now this tells me that we have also a horizontal shrink by a factor of 1 over pi. All right, so now let's build our graph. So we know that our period is 2. So half of 2 would be 1. This would be 1/2, and this would be 3 over 2, which is 1.5. Okay, so now we said that our first point, or our y-intercept, needs to be at the amplitude. So there's our 0, a. And now we're going to follow our pattern. So half right here, we're going to be back down to 0. At 1, we're going to be at negative a. 3/2, we'd be back up to 0. And then 2, we'd be back up to a. Okay, so now we have this shape of our graph here. And that's what our graph would look like for number 1. All right, number 2, we have f of x equals 1/3 cosine 1/2 of x. So our amplitude in this case is 1/3. So now we actually have a vertical shrink by a factor of 1/3. And then our period, or we know our value for b is 1/2. So for our period, we'd be 2 pi divided by 1/2, which would be like 2 pi times 2. So this is 4 pi. So this 1/2 right here tells me that we have a horizontal stretch by a factor of 1 over 1/2, so by a factor of 2. Now let's build our graph. So we know our period is 4 pi, so let's put that at the end. Half of that would be 2 pi. So now we just have pi and we have 3 pi, right, to separate that into 4 sections. So now we're going to start up here at 0, 1/3, and now we're going to go down to 0, down to negative 1/3, back up to 0, and then back up to positive 1/3. So we can see this one is a lot more, scrunched together. That would be our vertical shrink. But also we have a horizontal stretch, right? So it's really being pushed down and also out, down towards the x-axis, and then also away from the y-axis, okay? All right, and that is how we can graph some cosine functions.